Good morning, dear children. We already started chapter 2, and today it's fifth part. We already have seen that the mixture have mainly classified in two types: homogeneous mixture and heterogeneous mixture. Homogeneous mixture we also called as a true solution, and we have already seen its properties and examples. Right? Today we are going to learn or discuss about the suspension and the colloidal solution, and we will see about the properties and how it shows the Tyndall effect. Let's start about the suspension. So what is suspension? So suspension is actually a heterogeneous mixture. So in it the particles do not dissolve completely and they get suspended throughout the medium. So what is its definition? Its definition is it is a heterogeneous mixture in which the solute particle do not dissolve but remain suspended throughout the bulk of medium. We have already seen the activity 2.2. In that activity 2.2 in beaker C, what we have taken? We have taken wheat flour and it mixed with the water. Okay, and I think I hope you remember that we stirred so well so many times, but still after few second or few minutes the particle of wheat can settle down, and we have seen the two different layer that time, right? Upper layer is of water and lower layer is of wheat particle. Today I am taking ये मिट्टी लिया है मैंने, right? If I mix this mitti with water, okay, again it will show a suspension. I stir well for so many times, okay, but still after few minutes you can clearly see the two different layer. Okay, meanwhile we will see the properties, and तब तक ये settle down हो जाएगा, then I will show you the two different layer. So what are the properties of the suspension particles? Okay, so main suspension is a heterogeneous mixture. So your first point is it is a heterogeneous mixture. Second, the particle size is greater than 100 nanometer. It has a highest particle size. Okay, homogeneous में क्या था? Particle size is less than 1 nanometer, and here it is greater than 100 nanometer. Then particles can be seen by naked eyes. हम अपनी आँख से without using microscope हम उसके particles देख सकते हैं. So we can see by our naked eyes. Next is particles scattered a beam of light. Then a solute particle can be separated by the filtration process. हमने एक्टिविटी 2.2 में किया था. आई यूज फिल्टर पेपर एंड फ्लास्क एंड फनेल, और मैंने वो मिक्सचर जब व्हीट और वाटर वाला था वो मैंने पोर किया. देन we got the residue of that wheat particle, okay, on the filter paper. So suspension में क्या होता है? We can separate the solute particle by using filter paper or by filtration process. When the particle settle down, the suspension break. जब तक particle अंदर थोड़े dissolve है तब तक वो solution suspension solution है, वैसा बोल सकते हैं. Once the particles settle down and two different layer we can able to see, then that solution is no more suspension. और तब ऐसा हो जाने के बाद it does not scatter the light anymore. Now here at a lower layer there are so many particles of that soil. Okay, sand के mixture देख रहे हो आप नीचे particles, and upper layer is a dilute layer. Okay, अगर ऐसा हो जाता है, once we get a two different layer, and if we want to pass the light from battery or any laser light or anything else, तब ये इसमें से लाइट पास होके स्कैटर्ड होती नहीं है. Is it clear? Now let's learn about the colloidal solution. Colloidal solution is again one type of heterogeneous solution, right? And its definition is solution in which the size of a particle lies between the true solution and the suspension. So colloidal का जो particle का size है वो ना तो heterogeneous जितना है ना तो suspension जितना है. तो वो जो size है उसका दोनों के बीच का है. Okay, as you know, the particle size of heterogeneous is less than 1 nm or suspension ka greater than 100 nm. So, in short, the particle size of the colloidal solution is in between, lie in between 1 nanometer to 100 nanometer. And that's why we have seen the in activity 2.2 when we make a mixture of milk and a water. It seems like a true solution. हमको particles दिखाई देते नहीं है. We can't see from our naked eyes, right? But still, it has a two phase. It doesn't have a single phase. Why? Because the particles do not dissolve completely. Okay, and that we can show by the doing the scattering effect or showing the Tyndall effect. Okay, now it is a heterogeneous mixture. A component of it are not present in a one single phase but actually present in two separate phase. Now what are their two separate phase? Dispersed phase and dispersed medium. Now what is the dispersed phase? Dispersed phase is a solute-like component which has been distributed throughout in solvent-like medium. In short, जो भी solute है, it is we called as a dispersed phase. And what is dispersed medium? The solvent. The solvent-like medium in which the dispersed phase has been distributed is called the dispersed medium. And such heterogeneous system obtained is called the colloidal system. We are going to see the colloidal's example according to its state. Okay, now colloidals are classified according to the state of dispersing medium and dispersing phase. What it means? The classification of colloids is depending upon the physical state. Physical state means either solid or liquid or gas. Okay, physical state of dispersing medium. Dispersing medium here it means we are talking about solvent, and dispersing phase means we are talking about the solute. Let's see few examples which are given in table number 2.1. The common examples of colloids. So dispersed phase is liquid and dispersed medium is gas. The type is called the aerosol. An example is fog, cloud and mist. Second is solid, is a solute or dispersed phase, and they are distributed in dispersing medium which is a gas. Again it is a aerosol, a smoke, automobile exhaust. Such examples are given on table number 2.1. So do read it and try to understand what is the dispersed phase, what is the dispersed medium and its type and examples. Okay, this may be asked in 1 or 2 marks questions. Now let's see what are the properties of colloids. Now let's talk about the properties of colloids. As you know, it is a heterogeneous mixture. Particle size is in between 1 nanometer and 100 nanometer. Can't see with our naked eyes. Its particles are too small, so we can't see by our naked eyes. But enough, particle size is big enough to scatter the light. I will tell you about the Tyndall effect and how the particles scatter the light, and we'll share the video also related which shows the Tyndall effect of colloidal solution and the true solution. So particles are big enough to scatter a beam of light. It is a stable solution. Colloidal solution are we called as a stable solutions, because when we left the solution, any colloidal solution left undisturbed after 5 minutes or 10 minutes or even an hour, we cannot see the two different layer. As we already seen all these things in activity 2.2, हमने जो मिल्क और वाटर का सॉल्यूशन लिया था, मीन्स जो सॉल्यूशन बनाया था, तो उसमें हम if we left it as it is for an hour or 2 hour also, so we can't separate that milk particle layer. We can't see the two different layer. Okay, so we can say that it is a stable solution because particle do not settle down when left undisturbed. And what is in case of suspension solution? Suspension में क्या होता है? It is unstable. Why? Because after few second or minute we can say we can see the two different layer of dilute solution and the particles of suspension. And last one is solute residue. We can't separate by the process of the filtration. जब हमने मिल्क का सॉल्यूशन जो पानी में बनाया था तो हमने फिल्टर किया था, सो हमको दिखा था मिल्क पार्टिकल ऑन द फिल्टर पेपर? नो. So no such residue of milk particle we got at that time when we perform activity 2.2. So in short we can say that by filtration method we can't get the residue of the solute. So these are some properties of colloids. See, we have already learned about the properties of true solution and suspension. We have just seen, and just we cover this properties of colloidal solution. Try to write at least 7 or 6 differences between the true solution, suspension solution and the colloidal solution. Now I will show you what is Tyndall effect and how this colloidal solution show the Tyndall effect. Tyndall effect is a phenomena of scattering of beam of light, we can say, and Tyndall effect shown by the colloidal particles and the suspension particles. They do not show by the true solution. And why it is this? This phenomena of scattering light is actually is depending upon the particle size. As you know, the true solution has particle size less than 1 nm nanometer. So here I am showing you first figure. In that it is a true solution. In this beaker, the particle size is too small. When the torch is on, the light beam is impact on the beaker, the light beam goes, or it can move in a straight direction. It can't scatter. Scatter means ऐसे direction change होना. It can't scatter. Why? Because the particles of the solute are too small that they cannot scatter the light. On the other hand, in case of a colloidal solution and suspension solution, when we apply a light on this beaker which is filled with the colloidal solution or suspension solution, the particle size of the solute is too big that the light beam scatter, and therefore we cannot get a beam on the other hand. We get a beam in first case, but we cannot get a beam on the second case. Why it is like this? Because the particles scattered the light. Is it clear? This is called a Tyndall effect. I hope you got all this concept, and we will meet in next video soon. Till then, goodbye.